In the quiet town of Ulm, Germany, a young boy named Albert Einstein began a quest that would transform the face of science forever. Born into a modest family in 1879, young Albert was not your typical child. His early years were marked by an extraordinary curiosity and a peculiar way of thinking, which often put him at odds with the conventional schooling methods of his time. Imagine a boy so intrigued by the mysteries of the universe that he would spend hours staring at the compass his father showed him, mesmerized by the invisible forces at play. This was not just child's play, it was the beginning of a lifelong passion for understanding the fundamental laws of nature. As he grew, Einstein's fascination with mathematics and physics deepened. While his peers struggled with rote learning, Albert thrived on challenging traditional concepts, always seeking deeper understanding. It was this unique approach to learning, combined with his relentless questioning of the world around him, that set him on a trajectory towards greatness. From these humble beginnings, a genius was set on a path that would challenge the very fabric of the universe. As Europe stood on the brink of monumental changes, Einstein's groundbreaking theories of relativity began to take shape. It was a time of intellectual ferment, when the very foundations of physics were being questioned and redefined. Albert Einstein, a young patent clerk in Bern, Switzerland, was about to introduce ideas that would challenge our deepest understanding of the universe. Amidst his daily responsibilities of examining patent applications, Einstein's mind wandered into the realms of time and space. It was here, in this unlikely setting, that he began formulating one of the most revolutionary ideas in the history of science: the special theory of relativity. This theory emerged from Einstein's simple yet profound realization that the laws of physics are the same for all non-accelerating observers, and that the speed of light in a vacuum is constant, regardless of the speed at which an observer travels. This insight led to the famous equation E=mc², where E stands for energy, m for mass, and c for the speed of light in a vacuum. This equation suggested that mass could be converted into energy, a concept that would later have profound implications. Imagine standing still and watching a train speed by. According to relativity, if you could somehow observe the clocks on board, you would see them ticking slower than your own. This bizarre effect, known as time dilation, implies that time itself can stretch and compress. It was an idea that overturned centuries of Newtonian principles, which had viewed time as an absolute, marching from past to future at an unchanging rate. Einstein's theory also introduced the concept of length contraction, proposing that objects in motion actually shorten along the direction of their travel. This interplay of time and space, where both could warp and weave in response to speed, was a clear departure from the intuitive concepts of motion and position that had dominated physics. With these ideas, Einstein not only revolutionized our understanding of time and space, but unknowingly paved the road towards a formidable discovery. 1938 brought a discovery that shook the world: nuclear fission. In a modest laboratory in Berlin, scientists Otto Hahn and Fritz Strassmann were conducting experiments that would inadvertently change the course of history. As they bombarded uranium with neutrons, they observed something unprecedented. The uranium nucleus split into smaller parts, releasing a tremendous amount of energy. This phenomenon, later named nuclear fission, hinted at possibilities that were both exhilarating and terrifying. Albert Einstein, whose famous equation E=mc² had laid the theoretical groundwork years earlier, was indirectly linked to this discovery. His equation showed that mass could be converted into energy, and the amount of energy would be equal to the mass times the speed of light squared, a number so large that even a small amount of mass could potentially release an enormous amount of energy. The implications of nuclear fission were profound. It promised a new source of power that could, in theory, provide boundless energy. However, the same process that could light up cities and power industries had a darker side. It could also be used to create weapons of unimaginable destructive power. As the news of Hahn and Strassmann's discovery spread, the scientific community and governments around the world quickly realized the dual-use nature of nuclear fission. The race was on to harness this new power for better or for worse. This breakthrough was a double-edged sword, offering both limitless energy and unprecedented destructive power. With the world teetering on the edge, Einstein faced a moral dilemma that would define his legacy. As the storm clouds of war gathered over Europe in the late 1930s, a letter was crafted that would forever alter the course of history. Albert Einstein, the pacifist genius behind the theory of relativity, found himself playing a pivotal role in a drama he never wished to be part of. The discovery of nuclear fission by Otto Hahn and Fritz Strassmann had opened up the terrifying possibility of atomic bombs. Concerned by the implications, Einstein was persuaded by his colleague Leo Szilard to act. Together, they drafted a letter to President Franklin D. Roosevelt, warning of the potential for extremely powerful bombs of a new type, and advocating for the United States to accelerate its nuclear research. This letter, sent in 1939, helped initiate the Manhattan Project, ironically setting the stage for the atomic age. As the reality of atomic weaponry materialized, Einstein's initial apprehension turned into profound regret. He spent subsequent years promoting peace and the responsible use of nuclear energy, but the shadow of the atomic bomb loomed large. Einstein's pen had unleashed a genie that he would spend his life trying to put back into the bottle. In the shadows of Hiroshima and Nagasaki, Einstein's horror at the atomic bombings propelled him into action. The devastation wrought by nuclear weapons shook the very foundation of his beliefs about science and its role in society. This profound shock transformed Einstein from a physicist into a passionate advocate for peace. Einstein's involvement in the anti-nuclear movement was marked by his association with the Emergency Committee of Atomic Scientists. Founded in 1946, this organization aimed to educate the public and policymakers about the dangers of nuclear weapons and promote peaceful uses of atomic energy. Einstein, alongside other prominent scientists, took to the public stage, urging leaders and citizens alike to reconsider the path towards nuclear armament. His advocacy wasn't confined to closed-door meetings with political leaders, it spilled over into the public arena. Einstein's speeches and writings during this period were powerful and poignant, resonating with a global audience. He wrote articles and essays that appeared in magazines and newspapers, reaching people far beyond the academic and scientific communities. In one of his most compelling pleas, he famously stated, "The release of atomic energy has not created a new problem. It has merely made more urgent the necessity of solving an existing one." As Einstein campaigned for disarmament, his voice grew louder, echoing around the world. His calls for a global governance of nuclear weapons and his warnings about the consequences of nuclear war were not just cries in the dark, they were beacons of hope. Einstein's voice became synonymous not just with genius but with a fervent plea for humanity's survival. Though Einstein passed away in 1955, his insights and moral convictions resonate more powerfully today than ever. Albert Einstein, a titan of science whose name is synonymous with genius, left behind a legacy that transcends time and discipline. As we delve into the realms of modern physics, Einstein's theories of relativity continue to be the cornerstone upon which new scientific paradigms are built. His equations helped pave the way for everything from the exploration of black holes to the development of GPS technology. Yet it is not just the scientific community that owes a debt to Einstein. His moral foresight regarding the use of scientific discoveries is of equal importance. During a period when the world was teetering on the brink of nuclear war, Einstein emerged as a vocal opponent of nuclear armament. His famous letter to President Roosevelt in 1939 was a pivotal moment, highlighting the potential dangers of nuclear weapons. This act of conscience sowed the seeds for a global awareness of the catastrophic potential of atomic energy when misused. Today, as nations still grapple with nuclear proliferation and the haunting specter of atomic warfare, Einstein's warnings remain profoundly relevant. His advocacy for peace and his caution about the destructive capabilities of scientific advancements remind us that with great power comes great responsibility. In addition to his scientific and ethical contributions, Einstein's personal journey from a patent office clerk to a Nobel laureate is a testament to the enduring human spirit. His life story encourages current and future generations to pursue knowledge and innovation while upholding the highest ethical standards. Einstein's influence extends beyond academic textbooks and into the core of our global culture. His legacy acts as a moral compass, guiding us through complex geopolitical landscapes and urging us toward a more peaceful and sustainable future. Einstein taught us not only to understand the cosmos, but also to safeguard the human race's future within it. His legacy, a blend of brilliant scientific insight and profound moral integrity, continues to inspire and challenge us to think deeply about the role of science in society.
If you are new to the channel, subscribe it and share this video with your friends. Thank you for watching.